Hello, Algebra 2. Today we're going to start Chapter 2, which is called Linear Equations and Functions. So today's lesson is going to be on Chapter 2.1, and we're going to discuss functions and their graphs. So let's start with a little terminology, and you've heard it before, but it's been a while. So relation is a mapping or pairing of input values to output values. And you can see a mapping or a relation in a couple different ways, but probably the easiest way is to use that mapping. And so mapping would go from your x, which is your input values, to a y, which is your output values. And so maybe we have the numbers 1, 2, and 3 in our x, and 5, 10, and 15 in our y. And then you just show which x maps to which y. So maybe 1 maps to 10, and 2 maps to 15, and 3 maps to 5. And so that's a mapping. So this whole thing here is called a relation. So this is a relation. It's a mapping from the input values to the output values. Now some other terminology that goes along with this, so I've listed here domain and range. So your x is also your domain, those are your input values, and your y, or your output values, are your range. So several different words that all mean the same thing there. Okay. Now you can also show this in a table. So I could do a table of x to y, and it'd be 1, 10 would be an ordered pair, 2, 15, and 3, 5. So relation is a function when there is exactly one output to each input. So this is an example of a function because for every output there is a unique input. An example of a non-function would be if we said 1 to 10 and 1 to 15 and 3 to 5. So that right there, the fact that 1 maps to 2 different y values, and from a mapping, what that would actually look like is we just have 1 and 3 listed. You don't list repeaters, and we'd have 5, 10, and 15, and then you can see that 1 maps to 10 and 1 maps to 15, so you get the 2 arrows that are leaving from the same spot, okay? And then 3 would be to 5. So down here, but in the bottom, that's not a function. That top 2 examples, though, are a function. So a quick review of the coordinate plane. Okay, remember that your x-axis is your horizontal axis. Your y-axis is your vertical axis. You have the origin where the 2 axes meet. Starting in the top right, you have quadrant 1, and it goes around counterclockwise to quadrant 2, quadrant 3, and quadrant 4. Your quadrants are named with Roman numerals so that you know that you're talking about quadrants. And if we're going to graph, so we come from a table here, so I'm going to graph the point 2, 3, negative 4, 1, and negative 2, negative 5. So to plot those, to plot 2, 3, I'm going to go over 2 and up 3 and put a point. To plot, there we go, negative 4, 1, I'm going to go to the left 4 and up 1, and there's negative 4, 1. And to plot negative 2, negative 5, I'm going to go left 2 and down 5, and there's negative 4, negative 5. So what I just plotted on the last one was a relation. Okay? And so that's, again, it's just that mapping from input to output that I just happened to put on a coordinate plane. So if I graph a couple of points here, okay, so this is a relation. I can take these points off of that graph and I can put them in a table, and I have 3, 2, and I have 4, 4, nope, sorry, 4, 5, and and I have negative 5, 3, and I have negative 2, negative 4. Okay? So if you remember, you can use your vertical line test, and your vertical line test is, can you draw vertical lines anywhere, and they only pass through the graph once. So in this case, they only pass through these points once. And if it does, so this represents a function. So if we write, if any vertical line only passes through the graph once, then the relation is a function. So as is, this is a function. But if I come over and I add another point that has an x of 3, so let's say I do 3, negative 3, then this is no longer a function because I have this vertical line right here that's going to cross twice, and that would no longer be a function. So it works for points. It works if you just have a line plotted. That's a function because your vertical lines would only cross it once. If you have a circle plotted, though, that's not a function because your vertical lines would cross it more than once. So that's a function, and this one is not a function. Next, we're going to evaluate functions, and we're going to use function notation. So if we graph a line, and hopefully you remember slope-intercept form, we're going to talk about it in a minute, but let's say your line is y equals 3x plus 2. This is going to be a function, and so to note that it's a function, function notation is to rewrite it f of x equals 3x plus 2. So that's your function notation. Doesn't have to be f of x, it can be g of x, it can be h of x, okay? I mean, it really doesn't even have to be x. This is your variable, so if your variable is y or z, okay, and then this is your name of your function. So in this case, I have the function f that has the variable x. So that's what that would mean. So that's function notation. And if I want to evaluate the function, then maybe we say we want to evaluate f of 3. So this means find the value of f when x is 3. So to do that, you just plug in 3 for x. Okay, and you work out just the right-hand side here. So this is 9 plus 2. So this is 11. So f of 3 equals 11. This is the same thing as saying y is 11, because notice here f of x and y are the same thing. So when x is 3, y is 11. That would be a point on your graph. Okay, what if we find f of negative 1? So we're just going to go back to our original function, and we're going to type in a negative 1 for our x, and then we're just going to evaluate that right-hand side. Negative 3 plus 2 is negative 1. So f of negative 1 is negative 1. So when x is negative 1, y is negative 1. Alright, and finally today we're going to talk about graphing linear functions. So a function doesn't have to be linear, but right now we're just going to graph linear functions. And you're going to use one of your two forms, and sorry my graph covered y equals mx plus b, and so what I wrote on the other side was, as a function, that's going to be the same thing as f of x equals mx plus b. Okay? So we're just changing our y to an f of x. So when you graph, you're going to plot the b first, and if you remember that stands for the y-intercept, so first you're going to plot the y-intercept, and then second, you're going to count the slope to plot. I want you to do 2 more points for a total of 3. Okay, and then you're going to draw in your line and put arrows on the ends. So I'll give you one as an example here. Let's say we want to plot y equals, let's do the one we just did, 3x plus 2. Okay. So first of all, we're going to start at our y-intercept, which is 2. So on the y-axis, we put a point at 2. And then we're going to count our slope, and our slope is 3 over 1. So we're going to go up 3 and over 1. And if your graph prohibits you from doing that again, you can do the complete opposite, and we're going to go down 3 and back 1. There we go. So let's draw in the line, and we're going to put arrows on both ends. And then if you notice here, that point is what we just found when we evaluated when x was -1, y was -1. So there is a preview of function notations, graphing functions, and then also talking about relations. We'll finish it up in class. Let me know if you have questions, and have a great day.